Hello, everyone. Thank you for joining us today. We are going to go over the history of text generators up to the recently released GPT-4 and look at the reinforcement learning from human feedback, learning approach that ChatGPT uses to understand. Okay. We are going to go over the and our amazing speakers, Eugene Kolker, PhD, EVP Global Services, Director AI and ML, Director Client Success Accelerator at DataArt, Dmitry Baykov, Team and Teach Science Lead at DataArt, and Mykola Dudnik, AI and ML Experts at DataArt. Colleagues, the virtual microphone and the stage is yours.
Hello, everyone. Thank you, Alina, for introduction. That's Dmitry speaking. So welcome everyone on our webinar, and please meet Eugene and Kolya, and let's see our deck and start our small journey into AI thinking in a nutshell. So we would like to start from the brief history of AI and generative AI, and then we wanted to explain how large language models can think, and that's we will do with langchain, the tool set for doing really great things with LLMs and with prompt engineering. And then we'll speak a bit more about how we in DataArt use generative AI, and specifically about DataArt's AI Center of Excellence AI platform. So I'm happy to pass the word to Eugene Kolker to start with the brief history of AI.
Thank you, Dmitry. Thank you very much. Mykola, can you move to next slide, please? So we're going to cover very, very briefly history of AI and generative AI. By the way, this slide was generated with help of one of the most advanced tools to generate decks, gamma.app. Highly recommend that to you. Let's go to next slide. Earlier, I was chatting with ChatGPT, and my first question was when AI was born. That was the question on the top, and that was a decent, almost correct answer from ChatGPT. Everybody thinks it was introduced, this term, in 1956 at Dartmouth conference, and the person who introduced it was John McCarthy. Actually, that's almost true. I did know the correct answer, so I went to second iteration. Kolya, if you can move to next slide. Second iteration, question on the top, and the answer in blue is correct answer from ChatGPT. Actually, John McCarthy, he was below 30 back then. In 1955, together with 3 collaborators mentioned on previous slide, submitted grant application to Rockefeller Foundation to have a famous Dartmouth conference, which happened a year later. So actually, AI as a term is around for 68 years. It's very long. Let's go to next slide. Both AI and generative AI, which we're going to define next slide, is both these approaches are extremely useful, especially nowadays. Some people consider that on November 30th of last year, there was so-called ChatGPT revolution. I would concur with that. And earlier today, when we talked for a couple of minutes with Dmitry, I recollected that 25 years ago, one of my mentors told me, which he learned from the very top of Microsoft company. Back then, I lived and worked in Seattle. And the message was the following: AI will not take your job, but person comfortable with AI might do that. I think it's extremely exciting time right now, but it's also true right now. Until very, very recently, like half year ago, that would be too far-fetched consideration. But nowadays, you need to be very attentive to what is happening with AI, generative AI. Let's go to next slide, and the large language models, which ChatGPT is one of those. So again, here's the introduction of generative AI, and this slide was generated with gamma.app as well. Previous slide, gamma.app helped to generate, and then Mary helped to beautify it. But substance is here, okay? A generative AI is specific type of AI, and for daily usage, we are getting there right now. Of course, it has a lot of limitations, like we humans. Sometimes it's not correct, sometimes it hallucinates, sometimes it's not giving you what a correct answer should be, even if it knows it, like in previous example. But still, with all these limitations, is extremely, extremely powerful. Let's go to next slide. Especially nowadays, large language models, they are extremely powerful. And this is a diagram not generated by gamma.app, but by another company, which shows some history of large language models. Again, ChatGPT is one of those models, extremely powerful. So welcome to world of generative AI and large language models. Dim, I think floor is now yours.
Yes, thank you very much, Gene. And this is a great intro. And I encourage everyone from the audience, if you have any questions, write it down in the chat, and we'll answer them in the end of our presentation. And thank you very much, Gene. And now I would like to pass the word to Kolya, who will dive deeper into what ChatGPT is and what is langchain specifically.
Thank you, Dima. Hi, everyone. So now let's talk about what is ChatGPT and how we got it. So first that I want to say that inside of ChatGPT, in StructGPT, we have only same GPT-3 model that without any magic, that just predict a next word for a given sequence. So in our future discussion, we will use GPT-3 like our base large language model, because ChatGPT is built on top of it, and it's most breakthroughs product that use large language model. So how we get it? After release of GPT-3 architecture, OpenAI start working on InstructGPT models that just take the same GPT-3 trained model and apply to it reinforcement learning from human feedback. After this manipulation, they got a really powerful model, but a bit with unsafety output that can harm a user, like in times of DialoGPT. So how we can understand we can use this? We can't use this model for any product. So after some time, OpenAI applied safety to prevent harm outputs from the model, and we got a ChatGPT. So let's dive deeper. What is reinforcement learning from human feedback? Why it's helped OpenAI to get ChatGPT product, and why it's the future of any large language models for the next couple of years. So basically, let's start from reinforcement learning to revise what is it. It's just an approach for training your model to do some actions in given environment. So for example, your environment is a room, and task in this environment just move things around it. And so model will be do some actions inside of this environment, receive an output from environment, and give this output to the policy that will update model ways to do better interaction with with an environment. So basically, reinforcement learning has three objects: is policy update algorithm, models that do some actions, and environment where these actions applied. So how OpenAI applied these technologies to large language models? So firstly, they trained default GPT-3 model on the pile data set. So after that, they got a pre-trained model like it do that before for GPT-2, GPT-1, and any other LLM. After that starts their novel approach. So as we understand, in reinforcement learning, we have some things that update our weights based on model interaction with environment. Here, OpenAI take take a prompt dataset, pass it to language model, and get a various output for each prompt. Then they ask it a group of analysts to rank these outputs from better to worse, and have a new data set with model outputs ranking. So now we need to create a model that will give for this ranking a score. And they just collected these rankings, converted them using ELO to scores, and put it to this model. So they got a model that by given outputs for an each prompt, create a score. If the score higher, so this determine that for human it will be a good answer for this prompt. And then start reinforcement learning from human feedback. We take initial our model, so it's GPT-3 in this example, and make a copy of it. For initial model, we will froze all weights for it. For our copy, we unfroze all weights to be able to train them and change these weights. So then we have a data set of our prompts, pass this prompts through each of this model, put an output of each model to Kullback-Leibler divergence to create a shift penalty to not create a bias of our models, and then output of our unfrozen model we put to reward model. With output of our shift penalty and ranking from reward model, we put this information into policy update algorithms that just standard PPO algorithm from reinforcement learning. It updates weights of unfrozen model, and that's it. So in this way, trained GPT, Instruct GPT and ChatGPT and GPT-4. So by this ranking from reward models that we got, we can improve our model output to be better for human experts group that ranked all outputs for the given data set. So now with an information how it's work, how we get so powerful model, let's try to understand how to make it sync. So if you look on this diagram, we can see that human during solving some engineering problems use a lot of some actions in the reasoning, like step-by-step formatting of solution, interaction with other humans, gathering feedback, collecting information from different sources, to solve only one task. Our language models are also powerful, but when we try to solve some math word problems, fact-checking operation, and so on, regarding to that, it's just a model that predict next word for a sequence. We will get sometimes not a good outputs, and the community start to find a way how to make the AI think, how to add here reasoning, acting, and so on. So let's start with the first step with step-by-step reasoning, and this approach provided to us by chain of thought. It's an it's a research made by Google Brain team to how to add this reasoning step to our model. As you can see on the screen, by default prompting to large language model, we just provide a question and receive an answer. And with some simple math operation, math word problems, sometimes it can throw a wrong number as an answer because model just try to predict the next word in the sequence, and from this part of this task the output is correct, but from the logic part of this task we got an incorrect number. To solve this, they provide to us a way to add to initial prompt not only question and sample of answer, but step-by-step reasoning how to get this answer. So we can see on this example that we provide to a model a little told what she how need to think to get an correct answer, and then we provide a question and model provide to us its thoughts about how it solves this task, and we got a correct answer. So you can find more information about this concept in original paper, the link provided inside of this slide. So let's move to the comparison of chain of thought to default prompting. How we can see in this comparison, we use authors use math problems dataset, or all these three datasets, GSM 8K, MAWPS, and SVAMP is just a dataset that contain math problems from graduate school and differentiate between each of them only by complexity. It's only one difference between each of these datasets. How we can see for SVAMP, GPT and PAO model using chain of thought outperform prior supervised best model trained only to solve this task. So this approach is interesting for us, but he have some cons, and it's this cons that sometimes fact checking and tools can be wrong due to model will also predict them like trying to solve task to get next word for a given sequence. And to solve this problem, we have also another research from Google Brain team, synergizing reasoning and acting in large language models. So this approach provides to us a way how to solve problem of chain of thought when model create wrong thoughts about solving of task due to unknown correct facts and correct observation to use them in this chain of thoughts. And here the solution to this problem is just providing to our model a way to interact with environment. For example, with Google search. How you can see on this example, the question was what another device can be controlled by Apple remote technology. And as we see on the slide, if we use only chain of thoughts, so only reasoning, it will create wrong thought from its knowledge and give to us a wrong answer. If we use reasoning plus acting, so our model firstly decides that he need to get an information what is Apple remote, and the action here will be just Google Apple remote. Then from observation, from output from Google, we collect information that is originally designed to for front row media center program. Then next thought is understand what is front row, get information from Google, and after that, with latest observation, when we know all facts about our question, we model can provide correct answer. So this is the main concept of this research. Also, you can check it deeper in original paper, and comparing it with default prompting and chain of thoughts on hotpot QA datasets that provide to us some reasoning question when we need to compare facts and compare some axioms about data and question what we have. We can see that reasoning plus acting approach is slightly better than chain of thoughts, and if we combine them, chain of thoughts and React, we can get even better result. But for this example, for question answering on hotpot, supervised models for now is the best choice, but we have a good result using models that not trained on this data and not trained to solve these problems. And now knowing these approaches, how to deal with different prompting technique like chain of thoughts and React, let's talk about langchain because it's like a Hugging Face some time ago for a language model, but it for interaction with this model. It combines inside of it have all modules for provide to you React agents that will be able to interact with environment. It provide to you memories, indexes, provide to you ability to use vector database and manipulate data inside it. So it's very powerful tool that in couple of line of codes can create you an application using latest powerful language model. So now from this part, let's look on langchain and how it's work. So here we got a demo notebook prepared for this presentation. We will share it after this IT talk. So the start of this notebook is just collecting all requirements for this demo. You will need OpenAI library, langchain, Tesseract, Detectron, and ChromaDB and Pinecone API. So after installing all these dependencies, you also need to set up OpenAI API key, GCP project API key, and Google custom search engine ID to be able to share with your agent Google search abilities. And let's start. So how you can see the first benefit of langchain to prompt anything to your model, you will need only a couple of rows with initializing of your model. So in our case, it will be text DaVinci 003. It's basically the largest text variant of GPT-3 architecture. And the next one, which is interesting benefit also, is prompt template. How you can see, you can put all information inside of template and create some changing fields. In our case, this provides to us to create prompt like this. So top 3 ML ideas for 2023, and we can see an output from given model. Also, langchain have a few short prompt template when you can give to your model not only questions but also an answer to show what you expect from your model. In this case, we creating using few short prompt template an agent that will provide to you sarcastic jokes on your questions like what is the meaning of life, and let's move on to chains that provided by this library. So as you mentioned before, we have only we pass to our model only one request at the same time. So if we will not use chain, we will pass all of these questions independently by 4 times. But chain provides you an ability to put all this information in one request and get a structured output. So now let's look on dynamic chains and how React approach works inside of langchain. So first of all, langchain provide to you a big list of tools that can be used by your agent to interact with environment. So the interesting from this is like Python REPL is your model can interact with Python shell. Also, Google Search API, Paul Mass for solving some complex math problems, and so on. You can find the list of all these APIs and tools inside of this notebook. So we will use Google Search in our example and Python shell. So we're creating a zero-shot React agent and asking our questions. It looks like, can you print a square root of the distance in miles from New York to the current capital of USA? What our agent must do? So firstly, he must determine what is the capital of USA now, then find a distance between New York and current capital, and after that provide to us code that print square root of this distance. How we can see agent does it correct, so he get current action that he need to search distance from the New York to Washington DC, get correct distance, then try to write a code, but the first attempt was with an error because we don't imported math library, and then without any our interruption or help to this agent, we just agent by itself fixed this small bug and provide to us correct answer for our question and finish it his work. So using this technology, you can almost build an application or using only langchain. So now let's look an example with ChromaDB question answering. We will use for this also langchain, OpenAI embeddings from Text DaVinci model, and we will also use ChromaDB to store our text data and our vectors of embedding for this text data. For the text data, we will use essays data set with a couple of essays or some different topics, and small abstract from Medium paper about BERT topic. So firstly, one cool feature that provide you langchain is a text splitter. You can split your document by chunk size, by characters, by pages. It depends basically on your document. It's what looks like the output of this splitter. So you can see this is a text splitted by chunks of 1000 characters, and also we have metadata which source of this text was. So then we create an embeddings for our text database, upload it to ChromaDB, and after that we just querying it using langchain. So our question will be what is topic model, and we receive a correct answer from our document and receive a document where this answer can be found. Also, another example how to use how to create vector question answering, but with PDF and PyConDB. So I guess a lot of you at least once seen an attention is all you need paper. So we uploaded this paper to our environment langchain using Datacron, split it this paper to independent pages divided by chunk size of 1000 characters. Then we create again an embedding for each of these pages, upload it to PyCon, and asking our question what is attention. Firstly, PyCon provide to us where answer on this question can be in which document, and then with the same question we go to langchain and adding to question our PyCon result, and getting that attention is a mechanism used in the sequence modeling and so on from our paper. So basically, that's all. I give a word to Dima, and he will explain how we use these technologies in our AI platform.
Yeah, thank you very much, Kolya. Before we go into that, I want to re-emphasize on a couple of points Kolya made before. So generative GPT-3 was there for a couple of years already. We knew about this technology. It was predicting the next word, but no one found a lot of interest in it and business applications. Since the success of ChatGPT, a number of different tools started to evolve. And as you see, Kolya very, very briefly walk you through what langchain can do and how it can move only prompt engineering with generate me this text to totally new level, where you can work with business applications, apply it to long sequences, apply it to search above your knowledge base, ask the questions to the documents, receive the answer in a human manner. So you can build your own Google by your data or your own ChatGPT by your data and get the answers as someone explains to you. And this is only the beginning, because with langchain, for instance, you can connect different data sources. You can connect Google, Wikipedia, mathematics from Wolfram Alpha, Python, and ChatGPT. And ChatGPT will know everything about these sources and can apply to these sources if needed and aggregate the information. And what is more important, it can reiterate again as even more improvement, it can reiterate on its own answers and it can check its own answers, which is very important. And if you heard something about ChatGPT plugins, this is like open source analogy, which was there even before they announced it. So I highly encourage everyone to check these instruments, to try it out. It's very simple. You can write your own agents, your own plugins, and extend work with generative textual models. And this is only the second stage after generative AI. Now there are a lot, even more complex things like AutoGPT or Baby AGI, the open source projects which are doing similar things. They want to explain to a machine how to think, and they are basically autonomous agents that can order you pizza or buy you an iPhone if you write the commands, or they can generate the wholesale strategy or the marketing strategy or some content plan for you or the code. And they are working iteratively on thinking, setting the task, doing this task, replicating and reflecting on how it was done, and then like reiterating on those. So they're asynchronous and autonomous, and you can scale them. And there are a lot of those AI autonomous bots which are already around the internet. So this is the future we are going to with the generative AI and generative models. I wanted today to explain what we do in DataArt and how it is related to generative AI. So we have a number of internal accelerators/products, and one of them is DataArt AI Platform, where we applied the generative AI. It's one of the places actually we applied generative AI. So the platform by its own, it is targeted to data science, routine automation, to help to improve business, to integrate all the best data science, machine learning ideas into one business process, to enhance this business process, keep track of experiments, keep track of the data sets, and overall move quicker from assumptions to real results for business. And now we will see the video of how it looks like and what benefits it gives to the users.
Today, many companies use data science and artificial intelligence to make people's lives better. Smart recommendations, taxi price and loan estimation, insurance plan approval can be done in a matter of seconds. All of this is possible with AI automation. But how can you know that your company is ready to do the same? Do you have the data from clients? Do you want to improve your business? Yes and yes. You seem to be ready. And we are here to help you. Our platform is designed to make your data science journey easier and the most efficient. With a no-code stepper approach, you will simply input datasets, select a prediction target, and wait a bit for the system to find the best model fit for your data. The results page will display plots and reports that will give you a clear understanding of your data. You can even switch from no-code to code and generate open-source Python code for the pipeline. The dataset and experiment management pages will help you always find the datasets and keep your experiment results organized. Using our platform, you can find valuable insights from tabular, textual, and time series data. You can easily build the models from multiple relational data sources and deploy them for use in production when ready. With our platform, you will automate solving of your business challenges by moving up to 4 times faster in new data science projects, staying cost-effective. With fast and traceable experimenting, you can build 3 times more projects in the same time frame and increase the average project prototype success. Start your data-driven journey today with the AutoML platform. Together, we will transform assumptions into actions and take your ideas to the next level.
Yeah, thank you, Kolya. So this is brief overview of what we had, and as you see, it's the platform which is data science oriented. It uses so-called experiments which data scientists do a lot or did a lot in the past for merging data sets, for building the models, working with different types of data like time series, text, table data. And we developed a set of automated experiments which are covering the clients and the projects where we have the data and where we want to build the model faster and to select the best model. So there is a set of AutoML tools already there on the market. We have a number of those which automate different things from the data preparation to the model deployment. And with generative AI, we managed to extend this into not only data scientist-oriented flows, but into business-oriented flows as well. So since the generative AI technology is very easy to comprehend from the business side, we selected a number of business use cases like meeting analysis or data science code generation or plots code generation. And we started to build those. And what we saw that building single screen Streamlit applications with clear UI, understandable input, limited set of configs and parameters, it really helps to drive business forward. And now we have more than 7 of those, and we are extending them even more. So it's small applications which are built on top of generative AI and which are targeted to business use cases and different business domains. So we not only enhanced our internal product, but we extended it with a totally new functionality which was not there before and which is understandable and explainable and scalable for many of our clients. And why do we need this platform overall? Just to quickly speak about summary on the next slide, you will see that by our research, we see the significant time saving up to 4 times to average AI POC development time. So it's not only about using our platform, it's about using AutoML tools, boosters, accelerators, and it leads to fast experiments, fast hypothesis checking. And with the popcorns concept, with the small applications, we are having the first results of the business use case in just a couple of days. We have the web version, we have the SDK version, we have the dataset management and experiment tracking features, and that's all is focused to increase the main business metric. This platform is very helpful inside the company and for our clients. And now with generative AI, it will be helpful even more. So that's it today from our side. And thank you for your attention. We'll be happy to answer any of your questions. And I will go in the chat to see whether we have any. So I see the question from Matt, and Matt asks, does DataArt have thoughts regarding what is happening in the ecosystem beyond OpenAI? Are there other tools coming that may similarly be as powerful, impactful as ChatGPT? Thanks. So, Kolya, what do you think about that?
I think we in nearest future we will receive a lot of tools that will be maybe a lot of powerful than latest OpenAI ChatGPT. So also we have a lot of a big open source community, and as we all know, we have GPT-Neo that will allow you to build your own GPT-like model. So also not so long ago, Microsoft released a framework to build your own transformers trained with reinforcement learning from human feedback, and Microsoft OpenAI Azure survives. So in nearest future, not only OpenAI will provide to us a coolest model.
Yeah, I agree. And I would like to add that, for instance, Databricks company had a great use case of releasing Dolly, which is basically a generative model, which was in the first version built on top of Llama, which is Facebook version of LLM. But in the second iteration, they gathered the data set inside their company and they trained with reinforcement learning. They trained the new model, which actually outperforms Llama on a couple of tasks. So there are a number of those, as well as Google has its own Palm or BART, which is a product like ChatGPT, and Palm is more like GPT-3 kind of model. So we see that there are some like competitors, but for now they are not so open to use like ChatGPT. And the OpenAI services, as Kolya said correctly, are integrated into Azure. So as soon as you want to use it inside your client's infrastructure, or as soon as clients want to send some PHI data or private data into their model, you are going to use it, the API on Microsoft. So there are no open source alternative because Llama cannot be used commercially. So soon there will be a lot more of those models. We are taking a look at that, and for now we see that in production ChatGPT, GPT-3, 4, one of the best models which can be used. Okay, so let's move on. Thank you for the great question, Matt. Alexander writes, yesterday I fed all the 1,100 pages of the book Artificial Intelligence to that. Yeah, so you can also even fed books with the langchain, and you can ask the questions to the books. You can create your library and search very fast. So yeah, that's all available with langchain. So the next question from Kazi. Is it possible to generalize and automate the conversation performance from Facebook ads based on pixels, for example, using DataArt AutoML? So let me decompose this question. So generalize and automate the conversion performance. If you're talking about, can we predict the performance from ads by images? Can we predict CTR or some revenue? Yes, we can do that as soon as we have the data set to train on. So generative AI can guesstimate. For instance, you can ask ChatGPT, hey, here is the image, describe it into the words and ask how much money it can bring. But again, it will be just a guesstimate. ChatGPT is not good at doing regression or classification problems, solving those. But you can work with the proprietary data and with open source data, open source models, classical machine learning to build something that could do the conversion performance assessment, whatever it means for you, like revenue estimation or something else. Kolya, would you like to add something here?
Actually, no, we can provide at least that we can provide popcorn that can do this job if we will get a bit more information.
Yeah. So the data is important here. Okay, the next question is from Lorena. I'd like to ask you about the ownership of the code generated by ChatGPT. Could it bring any legal conflict if we use it to generate code for our projects? It's a great question, Lorena. Kolya, what do you think about that?
I guess the code generated by OpenAI models and any other language model can be just like open source code with open license. So it must not create any legal problem for you.
Yeah, I think the same. And you have the tools like GitHub Copilot, which basically use the same technology and generate the code for you. You can use it inside your project. And you can use the text generated via ChatGPT as well. So it seems like the code and text are the same artifacts, right? So ChatGPT do not, how to say, it cannot understand whether this code is secure or not secure, right? So it can just generate statistically what it thinks the right answer is. So you have always to check, you have always to understand what's the code, you have to understand the background and the language for you to use it. And the second point, you shouldn't use your project internal code and feed it directly into ChatGPT, because ChatGPT is public, free preview version where your prompt may be seen by OpenAI people for training or fine-tuning. So that's why if you are doing vice versa, you are showing some risks to your code base, and it may result into some leakage, which already happened with giants like Samsung, and I think that some more. So that's what I would not recommend. If you want, it's better to use the tools specifically for coding, or it's better to apply to Azure OpenAI services and ask for their help with if you have specific need. Okay, so the next question, how can I integrate the power of DALL-E and Midjourney in DataArt AutoML so that is some task that can be automated? Yes, that's interesting question. So we are not currently covering the image generation task because it's something more tricky for business to apply than working with text or tabular data. But for sure, if you have any ideas, feel free to reach us out on LinkedIn or by our email, and we'll be happy to discuss your ideas. And if we see the great idea, we may think of implementing it and work with you on this one. So we are open to any ideas and happy to discuss that. Okay, so the next question. This one is for you, Kolya. Which vector database do you prefer to use with langchain? Judging from the demo, they are Pinecone and ChromaDB, right?
Yeah, If look on the demo, I will prefer ChromaDB because we don't need anything to set up it. It can be easily set up just in your co-op instance. So if technology is so the easier technology that you need to use, then less time you need to spend to implement something. So I prefer in that case ChromaDB, but some preference for exactly that we need to use only this vector database I don't have, because these needs can be can depends on what is your project and how many data do you have. If we had a lot of data, I will prefer a Pinecone, because this database will manage all the cluster job and divided my data by clusters, backup of my data, and all of this by itself, and I will use only API.
Yeah, and I would add even more that as far as I remember, langchain has around 7 or 8 different vector databases available. So you can search the documentation and, for instance, plug in the Elasticsearch as a database. It may be done as well. So I think that it's worth checking langchain documentation, because it's very broad, very verbose, and I highly recommend to check it out. It has a lot of answers to many of your questions. But thank you for the question, Alexander. Let's move on. We have 3 more questions. Cool. The question is, are you trying to integrate this with Jira and automate some specific part of workflow? Yes, the answer we did. We have a couple of internal projects which I cannot share a lot about, but they are around how to structure the requirements from the client into Jira tasks and how to improve specific steps of the Jira workflow. For instance, like tagging of the tasks, or analyzing based on some experience who is the best person to do this task. And we did a couple of POCs with that and even integrated them with Jira. So we had this in live. It was not used by any project. It is not used by any project now, but for sure, Jira as a source of textual information, combining with Pinecone as well, will lead you to great knowledge base and great input for your request to ChatGPT or similar models. So yeah, it's a great place to work with. Okay, let's move on. One important downside of the new generative AI models is they are much harder to interpret and control than traditional generative models. Maybe it's traditional models just. Are efforts underway to overcome these control limitations? Kolya, what do you think? Is it much harder to interpret generative AI and control it than interpret and control traditional models?
I think it's we need to spend same efforts for this one, because here now with this language models, it's also traditional model. We get the benefit of like generative AI for this model from reinforcement learning from human feedback. So I think we need to spend same efforts. But if we look on some research made it by other teams when they place it GPT model inside of some environment, sometimes this model start do some not clear for us actions, and we need to make the work of these models must be moderated all the time.
Yeah, I agree. So I would say that the first part about the interpretation, it's like you can interpret it very well because it's text, right? And sometimes interpretation of like time series is much harder. But with control, that's true that with ChatGPT and these autonomous agents, right? You cannot. It's very hard to put the high mark. So there is a red line. You cannot cross it because it's up to them. And if we give them the tools, they can use them. And if we give them the bad tools, they will use the bad tools if they decide to. So this generative AI or ChatGPT is just simple classical machine learning on tons of data plus human selection on top of it. And that's what crafted us a great tool. And with traditional machine learning, with statistics, right, you have just, you are not generating something from the noise like these models do. You're generating something based on your internal like assumptions and logic, which was automatically created by the training process. So you, based on statistics, you do some formula and you have this red line. It's heavily visible. You cannot have revenue under zero, right? So the model cannot predict it. You don't. You can, if you train the model for 10 classes, you cannot get the 21st, right? So you totally see your red line. With generative AI, it's unclear, more unclear and more unseen. That's why we have all these safety complications, responsive AI, ethical AI, and very hard questions, which most of us cannot answer right now. So we have a hope that it will be somehow defined in future. Okay, and I can see the last question from the chat, on the chat from Yuri. Would it be possible to get a copy of a presentation via email or otherwise? I think that it's public, so I don't think it should be a problem. We will ask our coordinators of the webinar to do this if possible, and with the notebook as well. Okay. Then I see no questions. Let's wait for 1 more minute. Thank you for the great questions. We try to answer all of those. And as I said, feel free to find us on LinkedIn. We'll be happy to proceed the conversations and speak about the ML generative AI.
Yes, thank you, guys. Thank you. Thank you for your attention. And sure, we'll send a video and presentation to all registered. Thank you very much.
Thank you, Alina. Okay, then have a great end of the day. Bye-bye.
Bye. Thank you.
Bye-bye, everyone.
Thank you.